I introduced myself before. My name is Shelley Kriegler. I'm director of this project, and we are so glad to see several of you online again for one of our e-learning sessions. Our session today is going to be on fraction multiplication. These are the lessons that are in week 12, 12.2, and 12.3. Please don't notice that it says 12.13. That was a little typo, first mistake I ever made. No worries about that at all. We're going to be focusing on fraction multiplication, and I'm sure that you will agree that the procedure itself is not difficult. All students need to do to multiply fractions is to multiply across. But what seems to be confusing to students is that they somehow don't know when to multiply across. Sometimes they think they need to cross-multiply, cross-cancel. They don't understand the concepts. And so this operation, like many others, becomes a nonsensical operation because students have not been taught concepts to go along with their procedures. So today what we're going to be doing is we're going to be looking at some ways to help students make these operations a little more sensible. In this session we are going to be extending concepts of whole number multiplication to fraction multiplication. We'll be doing this by using repeated addition, which is a basic idea about multiplication, that multiplication can be thought of as repeated addition. We'll also be doing it by using the area model, and I noticed that Tony earlier had said that the students are having difficulty with the area model, so this will be an opportunity to revisit it. And then we're going to link those two concept methods to the procedure, the multiply across procedure. Okay, so here we go. We're going to be building our notion of fraction multiplication by looking at whole number multiplication to begin with. And your students do know from previous years that multiplication can be thought of as repeated addition. And we see here an illustration of that. Two groups of 3 can be thought of as 3 plus 3 or 6. And this kind of thinking works very well when we are thinking about fraction multiplication, as long as one of the numbers we are multiplying by, one of the factors, is a whole number. So below we can think of 3 times 3/4 as 3 groups of 3/4, which is 3/4 plus 3/4 plus 3/4, which is 9/4. Everybody get that part? Give me a happy face if you're with me so far. Thank you. Okay, we move on. All right, so I'm going to give you just a moment to give it a shot here and try something. Would you all grab your pens and your writing implements and fill in some of these for me? 3 groups of 5 could be written in a certain way, and thank you. And maybe someone can draw a picture to illustrate that. How about 2 groups of 2/5? If someone wants to take a stab at that one, that would be great. And you might want to try drawing a picture of that one too. So I think the idea of repeated addition is pretty easy for students, and using this idea to introduce fraction multiplication is useful, and that's what we do on the first couple of pages of week 12. And this particular exercise comes from SP 12 in week 12. One way to draw 2/5. Oh, someone's giving it a shot. Thank you. Thank you, Catherine. That one might be a hard one to do. I think your efforts are gallant here, but I think we're going to move on. What do you say? Pat, is that your little picture of 2/5? That's awesome. Okay, we're going to move on. Sometimes this medium works and sometimes it doesn't. Thank you, Pat, for trying. Okay, We're going to move on to the area model, which is where I think more of the interesting conversation is going to take place anyway. What I'd like you to think about here is to think about a, oh wait, I just lost my page, hold on. I'd like you to think about for a moment a small room, maybe a dog pen or a bathroom or something like that, that is 1 yard by 1 yard. That would be a really small little space. And I'd like you to think about cutting up a piece of rug that is a half a yard on one side and 2/3 of a yard on the other side. If we did that, do you see that we would have a piece of rug that fits inside of our 1 by 1 space, and that this rug would be 2/3 long, 1/2 wide, and would cover an area that is 2/3 or 2/6 of the space. What's interesting about this, I think, is when we cover this space, when we do the multiplication, the 2 times 1, the numerator, represents the number of squares here that we have. Notice that we still have 2 squares. And the number of units that the entire 1 unit square has been divided into is the product of the denominators. We're going to use this idea to find the product of some fractions. And I think that the idea of finding area where we think of the different factors as the length of the sides of a rectangle is really useful here, because the students can easily see that this rectangle is 2/3 long and it is 1/2 wide, and the area has an area of 2 parts out of 6, and the 2 represents the 2 units of the numerator, the 6 represents the 6 of the denominator. In the program on SP13, the students will be guided to do some problems where they are shading areas and finding products and observing that the shaded area is the number of units in the product of the numerator, and the denominator is the number of units in the whole. I'm going to give you folks just a minute to try these. Connie, could you work on number 1? Carol, can you work on number 2? Catherine, how about number 3? And Pat, could you work on number 4, please? Thank you. Susan and Tony, I'll get you on the next page. Okay, so we've got some, it's interesting how you did this. We've got 3 different approaches to shading, and I think they're worth discussing. Nicely done, everybody. So the first one, I think Connie did that one. She shaded 1/2 in yellow going across, and then 1/2 in red going down. And notice that the orange part, the overlap, represents 1/2 of 1/2, or 1/4 of the whole rectangle. In number 2, Carol looked at 1/4 and just drew a rectangle around a rectangle that was 1/4 of a unit wide. Let's see if I can mark that one here. So here's your 1/4 right in here. I did it in green. And 1/2 of a unit long, and so we can see that 1/2 of a 4th is 1/8. That's this area right in here, because the length of the rectangle has been divided into 4 parts, and the width has been divided into 2 parts. Thank you, that was nicely done. Catherine, I think this was yours, was shading 1/4 by 3/4, and so she first divided it into 4ths along the top and 4ths along the side, shaded 3/4 in red, 1/4 in yellow, and we see that 1/4 of 3/4 is 3/16, and that would be the part that is here, yellow and red. Thank you. And then the last one, which was done by Mark, I believe. Is that correct? Mark, give me a happy face if you did this one. Who did the 4th one? Mark and Pat? Okay. Pat did this one. Okay, thank you. So when Pat did this one, you can see here that she divided into 2/3 across the top and 3/4 along the side. And when we take 2/3 of 3/4, let's see, what do we got here? We've got 3/4 in yellow and 2/3 in, so we got 3/4 here going down and 2/3 going this way, and so the shaded area is actually, let's see if we can find it. I believe it's these 6 that are being outlined in here. Is that correct? I believe that is correct. I believe it's these 6 right in here. Whoops. It's these 6 here. Does everybody get this? How this works? Okay, great. We're going to move on then. Thank you. Oops, we're not going to move that far on. Okay. On the next page in your packet, question number 8, and the 8 didn't show up here, but question number 8 is a really important question, so I call your attention to it. This is the question where after the students have done these problems, we have them summarized. Very important that they go back, look at the results of the shaded rectangles, and observe that the numerator of the rectangle is the actual shaded part, the part we're looking for, and the denominator represents the number of parts in a whole. And this is how we establish the multiply across rule. Now, once the multiply across rule has been established, then we can have some fun, and we can actually use it to do some problems that are a little bit more complicated. Recall that when we are multiplying whole numbers, we can break apart the numbers. And I'm going to ask, let's see, Susan, can you do this problem, number 9? And Tony, you want to give number 10 a shot, and just write the numbers into the squares so that we can see how we can use the area model to multiply when we're doing not only whole numbers but fractions as well. I think this is really pretty cool because, as Tony just pointed out, 3 times 1/2 is 1.5. And so we see here that 6 plus 1.5 is 7.5, and that's a really nice way to multiply, I think. I hope you like that too. What property are we using here when we multiply, breaking up the numbers? Someone tell me in the chat window. Yes, distributive, distributive, distributive. Thank you very much. Okay, we're going to take a look at a problem which I think is kind of interesting actually, and will help you, I think, to understand a little bit more about using the area model to multiply. Suppose we wanted to multiply 2.5 by 2.5. I want you to keep this picture in mind because we're going to actually look at this in a couple of different ways. Ariel drew the picture this way in one of the workshops that I did. But when after she drew, which makes sense because it's 2 and a half, 2 and a half, but she had trouble adding up the pieces. And I'm wondering if we could help her to add up the pieces. Would you all, collectively write in the area of each of these pieces? For example, the area of this one by 1 is 1. So go ahead and chime in and write in the areas of those different pieces. And let's see if we can figure out why Ariel was having some trouble. Okay, anybody have any thoughts? Please put it in the chat window about why Ariel might have had trouble adding up these pieces, where you think she might have had some trouble. Yeah, Susan, you're absolutely right. It's the extra fourth that was down in the bottom that really gave her some trouble. She was okay with the 1 and the 1 and the 1 and the 1, that's a 4. And she actually was even okay with the 2, the 1/2 and the 1/2 makes a 1, and 1/2 and 1/2 makes a 1. So she was okay with getting that the whole thing was 6. It was just this part right here that caused her some grief because she wasn't quite sure what that was. And so I'd like you to keep this picture in mind, and I would like to show you a couple other pictures that I think would help Ariel and will also help you if your students have the same difficulty that Ariel has. Let's take a look at it this way. How is this picture different than the previous one? I'll go back to the previous one again. Okay, take a look at this one. It shows the 2 and a half and the 2 and a half. And now take a look at this one. Would you comment in the chat box, how is this picture different than the previous one? Okay, so Tony says same size squares, which is true. And Catherine says it's 3 by 3, which is also true. Carol says the fractions are shown in relation to a whole, which is also true. And so if we were to mark off our 2 and a half by 2 and a half here, it would look something like this, and everything in between. Watch me scribble like a kindergartner. Yay for me. Okay, not the part that's outside the line. I think that this picture might help someone to better understand why this part is 1/4. Can you see it better, why this is a 4th in this picture? If you can, give me a little happy face. And if you can't, give me a little squiggly face. Thank you. So when we're multiplying fractions that are mixed numbers, and the students are having difficulty using the area model, one thing you might think about is just having them begin by drawing unit squares that are rounded up, if you will. So rather than 2 and a half by 2 and a half, go to a 3 by 3 square, and then find your area inside of that square. And that way, it might be easier for them to find the areas of some of those rectangles inside of the rectangle. Hope that makes a little sense. Here's another picture that I think is kind of interesting to take a look at. How is this picture different than the previous ones? Let me go back and show you the previous ones again. In this one, we had 1, 2, 3, and then they were subdivided up. In the previous one, we simply did our 2 and a half by 2 and a half. Now we go to the third one, and how is this picture different than the others? Thank you, Pat. Each of the boxes is divided into a half. Okay, we've got the whole thing in increments of a half. So this is another way that you might draw the picture that makes it a little bit easier for students to see what's going on. And one of the things I like about this picture is that if you actually look at it, on the top we have actually 5 halves, and on the side we have 5 halves. And if you multiply 5 halves by 5 halves, you end up with 25 pieces inside your rectangle, and each of those pieces are fourths. And actually, that is what the multiplication would look like if we changed these to improper fractions and multiplied across. Let me see if I can write that for you. So basically what we have is 5 halves, which is not written very well, that's times 5 halves, and that equals 25 fourths. So we have 5 across is our unit, is our division unit, and 5 down, and 5 times 5 is 25, that gives us our numerator, and each one of these pieces is a fourth of the entire square of 1 square unit, making it 25 fourths. So that picture actually gives us another way to see why the multiply across algorithm works. Okay, so now we can get more fancy again, and on page SP15 in the multiply across section, we see problems. We see a problem where we are multiplying 2 mixed numbers, and I'm going to give you just a moment to play with that. Let's see, how are we going to do this? I'm just going to let you have a free-for-all and see if you can fill in some of these blanks, and take note of how you can use the area model, or how you can add up the sum of the parts, how this translates into multiply across, or how it translates into using improper fractions. As you're working, I'm reading through some of your comments in the chat window, and I see, Carol, that you wrote that you can see that the fractions are in relation to the whole, but I don't understand your comment about the common denominator of 1/2. If you could explain that a little more, I'd appreciate that. Nice to see so many people participating today. Thank you very much. So in this problem, one of the things that might seem a little bit odd is that we're multiplying the 2 times 3 is 6, and then 2 times 3 fourths, which gives us either 6 fourths, it gives us 6 fourths. And this could have been done using an area model, but just as with regular multiplication, we hope at some point that the students have learned some facts and can do the problems automatically. The same thing would happen here, that we would hope that students could multiply 2 times 3 fourths and get 6 fourths just by beginning to multiply across. Same thing here, 3 times a half. 3 times a half is 1 1/2, or 3 halves. And 3 fourths times 1/2 is 3/8. In response to Carol's comment in the chat box again, the problem 2.5 times 2.5 is a really nice one as an example. You're right, because it's easy to see the halves and the 2.5 and the 5 halves. And one of the things that I think is really important when we model problems in class is that we pick our numbers carefully to illustrate the concepts that we want to illustrate, and then move on and extrapolate into more abstract notions, because that's what math is all about. Whoops, I think I moved too quickly. So this page, when you work it with your students, is intended to give them a side-by-side look at the area model and the multiply across rule, and also to verify that the area model, when you add up all the fractions, gives you the same result as the multiply across rule when you change them into improper fractions. Moving on, when we get into lesson 3 in week 12, the students will have simplification added to their toolkit of multiplying. And so you will see some problems like these where they're given a problem and asked to do it using multiple strategies. Repeated addition is a nice strategy when you're multiplying by a whole number. Then we can use the multiply across rule to verify that the answer is correct. And then you can introduce to the students the idea of simplifying, which is really using the big one, the multiplication property of 1, before we multiply, so that we don't have to work with such big numbers. When I was a kid, I used to love using simplifying because I didn't like to multiply big numbers, and I'm sure other kids felt the same way. Also, when you get into the third lesson, there will be multiple opportunities for students to do the same problem using the area model and other strategies. Here's an example where they're going to be using the area model to multiply 2 fractions, and then again try it with multiply across, and then try it with simplification. Does that all make sense to everybody? Makes sense to a few of you. That's awesome. Well, thank you very much. I think we're about done here. We are about done here. And I thank you all for coming. I hope that that has helped you to understand a little bit more about what we're doing with the multiply across rule and the area model with multiplication of fractions. I think this lesson illustrates a lot of the commonalities, a lot of the things that we're going after in the program itself. That is, we're using pictures and numbers and symbols and words to illustrate mathematics. We are working very hard not to just give kids rules, but to give them rules with explanations and concepts to back them up, so that if they do forget the rule, they have some tools to rely on to make sense of the procedure when they're trying to figure out what they're doing. And so that's what we're doing with the multiplication of fractions unit, and I hope that these pages will help your students understand a little bit more of what it is about. Like I said before we began, some of you were online and some of you weren't. Next week we're going to be doing division of fractions, and it's a pretty meaty topic. And so I'm interested in knowing whether you would like to spend our time looking more at the concepts from an adult perspective, or whether you would like to look at the pages in the program itself and just look at the problems themselves, or have a little bit of an extended session, more than a half hour, where we take a look at both. So if anyone's interested in giving me some feedback on that, I would appreciate it. You can give it to me in the chat window. I'll be on for a little while longer and can cyber chat with you. And I thank you very much for your participation. Bye-bye.